All right, number 6, decide whether or not the functions are inverses of each other. Use the definition of inverses to decide whether f and g are inverses. And we've been given f of x equals 3x minus 3 and g of x equals 1 over 3x plus 1. We're going to use the chart from page 387 there off to the right, you can see, to help us. And it says let f be a one-to-one function. So we've got to make sure that f is one-to-one. And if f is one-to-one, then g is the inverse function of f if these two things are true. When we compose f of g of x, if we get a single x, if we are able to simplify to get an x, then we can proceed, compose f of g of x, simplify, clean it up, and hopefully also get an x. And if these two things are true, if we're able to simplify down to x for both of these compositions, then we know that f and g are, in fact, inverses of each other. So let's go back to the beginning. Let's make sure, first and foremost, that f is one-to-one before we begin. Now, looking at this, we have f of x equals 3x minus 3. We know that this is the graph of a basic linear equation, so this is one-to-one. But just, again, for the sake of practice, let's use f of a equals f of b to confirm that this is one-to-one. So, again, we're using f of a equals f of b. In order to set this up, we need to know what f of a is, and we need to know what f of b is. So let's go ahead and find those two things. So f of a, we're going to take our original f function and simply swap out the x for the a. So we'll have 3a minus 3. Let's find f of b. Again, take that original function. Anywhere we see an x, we're taking the x out and instead putting in a b. So we'll have 3b minus 3. And now that we've found f of a and we've found f of b, we're going to set those two things equal to each other, clean it up, and see if we get a equals b at the end. So we'll have 3a minus 3 equals 3b minus 3. We can add 3 to both sides. The 3's go away. We're left with 3a equals 3b. If we divide by 3 on both sides, our 3's cancel, and in fact we are left with a equals b. So now we know definitively, we've confirmed that f of x equals 3x minus 1 is a one-to-one function. So let's proceed and see if we can find, or rather determine, if f and g are inverses of each other. So first things first, we want to compose f of g of x and see if we get x. And all that means is that we're going to take the g value, that g function, plug it into the f function right where we see the x. And so we're going to say f of g of x is equal to 3 times, well, what is the g function? 1 over 3x plus 1 and minus 3. All right, we can go ahead and distribute this 3 on the outside, and so what we end up with is 3 over 3x plus 3 minus 3. But we know that 3 over 3 is simply 1, right? And so we can say x plus 3 minus 3. Well, here we can see that plus 3 minus 3 cancel. And so indeed, we do end up with a single x. We were able to simplify it down to a single x. So things are looking good. Let's go ahead and finish by finding the g of f of x composition, see if we get a simple x. So let's now do the reverse. So we're going to take 3x minus 3, plug it into the g function wherever we see an x, clean it up, and see what happens. So we're finding g of f of x. And again, that will be 1 over 3 times the f function, which is 3x minus 3 plus 1. Again, we're going to distribute just like we did before. Here we're going to get 3 over 3x minus 3 over 3 plus 1. But again, we can reduce these fractions, right? We know 3 over 3 is just 1, so that becomes a single x. Here, 3 over 3 becomes 1, and so we can see that -1 plus 1 goes away, and again, we are left with a single x. So because we were able to get a single x when we did both of these composites, we do know that f and g are inverses. We verified it, we've confirmed it, and so there we go. We were able to get x from both compositions, and now we know. If, however, we weren't able to get x simplified down to x for both of these compositions, just like with number 5, then we know that f and g are not going to be inverses. But here at number 6, we have inverses.